This is lesson 4.3, solve mixture applications with systems of equations. Our learning objectives are to solve mixture applications, solve interest applications, and solve applications of cost and revenue functions using our abilities with systems of equations. You'll recall there are three methods for solving systems of equations: graphing, substitution, and elimination. Today we'll mostly be using substitution and elimination to get it done. So uh, let's begin talking about solving mixture applications. Here's example 4.24. A science center sold 1,363 tickets on a weekend. The receipts totaled $12,146. How many $12 adult tickets and how many $7 child tickets were sold? I've created a table. Now, when you're testing, you'll be the one that creates a table like this if you want to organize the information ahead of time. I highly recommend it. It makes creating the system of equations much easier. Now, what are we dealing with? We're dealing with adult tickets and child tickets. So I'll write the type of tickets right here, adult versus child. Okay, and the thing I don't know is how many adult tickets there are. I'll call that the variable A. And we don't know the number of child tickets either. I'll call that variable C. And I'm just picking variables based on, you know, distinguishing adult tickets versus child tickets. That'll make my life really easy when I get the answers of knowing what I just found. I do know that the value of each adult ticket is $12, and the value of each child ticket is $7. And then if I multiply the number of adult tickets sold with their value, I'll get the total value, right? So I know that the total value for adult tickets will be 12 times A. And the total value for child tickets will be 7 times C. And I do know that the total ticket receipts was $12,146, and also that there were 1,363 tickets sold. So let's input that information in. Well, I've got 1,363 tickets sold, so that's my total number of tickets right there. And then the total value was $12,146. Now I could take these two columns, the number column and also the total value column, and create a system of equations with these two columns by adding the pieces together and setting equal, like this. All right, so I have just found my system of equations from organizing this information. So my first equation, nice and easy, A plus C equals 1,363. And then my second equation, 12A plus 7C, that equals 12,146. All right, so there I have created a system. And then I ask myself, how do I want to solve this system? There are two main methods that you could use at this moment. That's either substitution or elimination. So perhaps you decide to use substitution. I will show you a process of using substitution. So I take that top equation and I solve it for one of the variables. In this case, I'll solve for A. So A is equal to 1,363 minus C. That's what A equals, right? What I just did was I subtracted C from the left-hand side of the equation to the right-hand side of the equation. And now I could take this stuff that I know A equals and substitute it in for A in the second equation. There it is. So I'm going to rewrite the second equation. 12 times A, which is 1,363 minus C, plus 7C equals 12,146. Great. There we go. Now, this is an equation that only has one variable, C, and it's a linear equation, so I can solve it. Okay, so now we talk about solution methods for linear equations, which we've discussed on many occasions. And I get 12 times 1,363, which is 16,356, minus 12c plus 7c equals 12,146. I can now subtract 16,356 from the left side to the right side. Great. And I can combine like terms, right? Negative 12c plus 7c. So I'll write that over here. Negative 12c plus 7c is negative 5c. And that equals 12,146 minus 16,356. Well, that brings me to negative 4,210. I'll now divide by negative 5 and come to the conclusion that C, well, that equals 842. So I've just discovered that there are 842 child tickets. Okay, so I've solved for one of the variables. That makes me feel very good. And now, little reminder, we could take that answer we got for C, 842, and plug it in right here for C, and we now have an equation that we can solve for A. Let's go ahead and do that. Or even better, we could take that answer, 842, and replace it with C right here, because this equation is already solved for A. I'll do that. So I now know that A is equal to 1,363 minus 842, which means A equals 521 adult tickets. All right, zooming out, what have we just gone through? We've just gone through a process of finding, based on the information given, how many adult tickets were sold and how many child tickets were sold. We had to create a system of equations from these two columns of information. Here's that system we created. I decided to use substitution. You could have also used elimination to solve. But here I went through the process of substitution and I solved for C, the number of child tickets. I then plugged that answer in for C right here to solve it for A. And here's that work right here. Great. Now let's move on to a new example, example 4.25. Juan has a pocket full of nickels and dimes. The total value of the coins is $8.10. The number of dimes is 9 less than twice the number of nickels. How many nickels and how many dimes does Juan have? All right, well, what type of coins are we dealing with? This is a coin problem. We have nickels, we have dimes. Great. And, well, let's call the nickels, we don't know the number, let's call it N. And the dimes, we don't know the number, let's call it D. But we do know that the value of a nickel is 5 cents, or 0.05. And the value of a dime is 10 cents, or 0.10, when we're talking about dollar value. Now, the total value of these coins is the number of nickels times 5 cents, and the number of dimes times 10 cents. We can write that here and here. So I have 0.05 times N and 0.10 times D. And I do know that the total value is $8.10. So I can write $8.10 at the bottom here. That's the total value of adding these two pieces together. This plus this must equal $8.10. Okay, so I have an equation right here from this column that I can create, and that would be just taking those two pieces and adding them together to set them equal to $8.10. And I also have a comparison with the number of dimes and the number of nickels, right? This sentence says the number of dimes is 9 less than twice the number of nickels. So I can create an equation from that. Let me create the system for you so you can see it very clearly. I have 0.05 times n plus 0.10 times d equals 8.10. That's my first equation. And my second equation is d equals, well, 2 times n minus 9, right? The number of dimes, d, is equals, well, 9 less than, okay, minus 9, twice the number of nickels, 2 times n. There you go. So d equals 2 times n minus 9. That is a second equation. Well, I've got a system. Here it is. And now it's time to decide what method I would want to use. And since d is already solved, right, it's 2n minus 9, well, I can just go up here and replace this d right here with 2n minus 9. So I'm going to use substitution in this case. So I'm going to write my first equation out, 0.05n plus 0.10 times 2n minus 9 equals 8.10. All right, so I just took d right here in the first equation, and I replaced it with 2n minus 9. Great. I can now solve this equation for d. Oh, sorry, for n, right? N is the variable that's left over. I only have n's in this equation. I will solve for n. And so I distribute, and I'll rewrite my equation as 0.05 times n plus 0.20 times n minus 0.90 equals 8.10. And now I'll take the constants and move them all to one side of the equation. So I'm adding 0.90 from left to right. And I will combine these two terms within n, and 0.05n plus 0.20n is 0.25n. So I'll write that here. 0.25n is equal to, well, 8.1 plus 0.9, which gives me 9.0. Okay? And now, to finish, I will divide by 0.25 from left to right. And I find out the number of nickels. Well, that's going to be 9 times 4, 36. There are 36 nickels. Okay, now that I have found the amount of nickels, it's time to find the amount of dimes. And you'll recall, wait, I can take that n is 36 and replace this n with 36 to find the number of dimes. Okay, so I'll take that equation, d equals 2n minus 9, and I'll replace n with 36. And 2 times 36 is 72, and 72 minus 9 is 63. So I have just found that there are 63 dimes. And I have now solved this system of equations for the number of nickels and dimes that Juan has in his pocket full of nickels and dimes. Let's move forward to example 4.26. Carson wants to make 20 pounds of trail mix using nuts and chocolate chips. His budget requires that the trail mix costs him $7.60 per pound. Nuts cost $9 per pound, and chocolate chips cost $2 per pound. How many pounds of nuts and how many pounds of chocolate chips should he use? All right. Well, let's organize all of this information into a table. This is what the table would look like that you create. It has the type, like we're talking about nuts and chocolate chips, right? So I will put that in here. I'll put chocolate chips. And then I'll put nuts. And then I'll have the trail mix, which is the combination of those two things. Okay, and well, we know that Carson wants to make 20 pounds of trail mix, right? So the total number of pounds of trail mix will be 20. I'm going to put that there. And his budget requires the trail mix costs $7.60 per pound. So the value for the trail mix is $7.60 each pound. And then $9 per pound for the nuts. And then $2 per pound for the chocolate, right? So, really I could just put a 2, since this is exactly $2 a pound, and a 9. Let's make life easy. And how many pounds of nuts and how many pounds of chocolate chips should he use? That's what we need to find. And let's say that the number of pounds of chocolate is C, and the number of pounds of nuts, let's call it N. And so now I can multiply the pieces together, like C, the thing I don't know, times 2. Well, that's 2C. 2 times C. And then the number of pounds of nuts times 9 is going to be 9C. And I can also find, the 20 pounds of trail mix that I want to create times $7.60 per pound. That gives me a total. I can multiply these together, 20 times 7.6, and that gives me 152. All right, so I have now filled out my table, organizing information, and putting names of variables of things that I don't know. And I now take this column and I create an equation with it. And then I could take this column and I can create an equation with it, like this. And why wouldn't I take this column? Because I know all the values of this column. I'm not worried about this information. Okay, so now I proceed to write these equations out. Oh, by the way, this is not a C. This is definitely an N, right? Because 9 times N. 9 is multiplied with N. I apologize. There we go. And so we move forward and we say, well, C plus N equals 20. And also 2C plus 9N equals 152. This is my system of equations. And at this moment, you are the one that decides. Do you want to use the elimination method, or do you want to use the substitution method? And maybe I'll just have fun and decide to use the elimination method. But I could very well have chosen the other method. So, the way I see it, if I multiply this equation by -2, then I will be able to eliminate the variable C. Let me rewrite the two equations, having multiplied the top equation by -2. And I get -2C minus 2N equals -40. And then on the bottom, I keep it the same. It's the same equation. And maybe you didn't realize that you could multiply an equation by any value you want to, right? And it's still the same equation. This is the same equivalent equation as this one. And so now you know you can multiply any equation by anything you want to, any number, except for 0, and you will get an equivalent equation. And why is that so cool? Because now I can use the elimination method by doing stacked addition to these two equations. Yes, you didn't know that either, but now you know you can add two equations together with stacked addition, or if you ever wanted to, you could also do stacked subtraction. It works in both cases. But in this case, I'll want to add because I have -2C plus 2C, and the C variable becomes eliminated. That's why this is called the elimination method. And now I will take -2N and add positive 9N, and that gives me 7N. And I take -40 and I add 152, and that gives me 112. And then I divide by 7, and I find out that the number of pounds of nuts that I need is 16. I need 16 pounds of nuts. Great. Now I know that N is 16, and I can plug that knowledge into any one of the equations I had along the way. either this one, this one, this one, or this one. But I always pick the easiest one. Like this one says C plus N equals 20. So I'll take that equation, C plus N equals 20. But I know that N is 16, so I will replace this N with 16, and I will solve the equation for C. It's quick. All I have to do is subtract 16, and I find the number of pounds of chocolate chips is 20 minus 16, which is 4 pounds of chocolate chips. And, personally, for myself, I am bummed out because I would much rather have 16 pounds of chocolate chips and only 4 pounds of nuts in my trail mix. In fact, I'd rather just have 20 pounds of chocolate and not have any nuts. What is your opinion? But this trail mix seems like it's a bummer to me because I'd rather have way more chocolate chips than I do nuts. Great. So there we go. We have solved the system of equations, and we know exactly how many pounds of nuts and how many pounds of chocolates are required to produce the parameters in question, right? I need 20 pounds of trail mix total, and it has to satisfy all these conditions, and yes, we have done it. Let's move forward into our next example, and example 4.27 has to do with Sashina. Sashina is a lab assistant at her local community college. She needs to make 200 milliliters of a 40% solution of sulfuric acid for a lab experiment. The lab only has 25% and 50% solutions in the storeroom. How much should she mix of the 25% and the 50% solutions to make the 40% solution? Great. So let's organize this into a table. In fact, this table would look like this that you create, and we'd have the number of units, right? And that would be the milliliters, right? Number of units of a certain concentration. And then we'd have to multiply that by the concentration percent, and that will equal the amount of solution. Okay? Now, the way I see it, we're dealing with a 25% solution. We're dealing with a 50% solution, and we have to combine them together or mix them together to make a 40% solution. So these are the types of solutions we're dealing with. Now, we don't know how many milliliters there are of each of these two solutions, the 25% and the 50%, but we do know that there are 200 milliliters of the 40% solution. So I can put 200 right here. And I'll just call the amount of 25% solution X and the amount of 50% solution Y. Those are the things I'll want to find, right? They ask me how much of the 25% solution and the 50% solutions need to be mixed to make the 40% solution. So I have to find this value and this value. That's the goal. Now, the concentration is literally the percent type, but we have to write it as a decimal. Or in this case, I guess we could keep it as a percent. Yeah, that works just fine. So I'll put the concentration percent as 25 and 50 and 40. You could always write these as decimals and it would work just the same, but why not just get rid of any decimals needed? That's what I'm going to do today. And so now I'm going to take the number of units X times the concentration 25 and write it right here. And that's 25X. And then Y times 50 gives me 50Y. And then, oops, forgive me, 200 times 40, well, that gives me 8,000. So 200 times 40 gives me an 8,000 right there. And I can take these columns, right? These columns that are filled out, and I can create equations with them. Like this column here at the end, I could add the pieces and set equal. And this column as well, right? The number of units column, I can add those pieces together and set them equal. So that gives me my system of equations. Nice and easy. X plus y equals 200, and 25x plus 50y equals 8,000. There's my system. And I can solve it by substitution or elimination. It doesn't matter. What I'll do for fun, I'll just decide, hey, let's do substitution this time. It's good to mix it up to practice both. And so I'm going to solve the top equation for x and say x equals 200 minus y. Okay, and then I'm going to go to the x variable in the second equation and substitute in 200 minus y for x. So it'll all look like this. I'm going to rewrite the second equation, 25 times 200 minus y plus 50y equals 8,000. And this is a linear equation that I have created with only one variable that I can solve for that variable y. And so I'll do it now. Here's where you think of your solution strategies for linear equations. So 25 times 200 gives me 5,000. Let me do it in blue. So 5,000 minus 25y plus 50y equals 8,000. Now I'm going to move the constants all to one side. I might as well subtract the 5,000 from left to right, and then I'm going to combine my terms with y in them. Negative 25y plus 50y gives me 25y total. So I have 25y equals 8,000 minus 5,000, which is 3,000, and then dividing by 25. I now have found what y is. Y equals, well, that's 120. Okay, so I have found 120. Well, what does that represent? I need a real world context. I said y was the number of milliliters, right? We're talking about milliliters of the 50% solution. So 120 milliliters of 50% solution. Great. Okay, so we've got that all worked out. There we go. And so now I move on and I need to solve for x. But now that I know what y is, it's very easy. I could take this equation x plus y equals 200 and replace y with 120, right? So I'm taking this equation, x plus y equals 200, and replace y with what we know, 120. And so now I subtract 120 from left to right, and I find out that x equals 80. Well, yeah, 200 minus 120, 80. And what did that x represent? Well, x represented the number of milliliters of 25% solution. That's what we said x represents. So I'll write that in context. So I'm going to write 80 milliliters of 25% solution. And I am done. We have solved this system of equations, and this is a great example of a mixture problem. Yeah. So there we go. Let's go ahead and move forward, and we're going to solve some interest applications. Okay. So you'll remember that simple interest, is I, the interest earned, equals P times R times T, where P is the principal, the amount that you invested. R is the interest rate, represented as a decimal. So if I had a 5% interest rate, I'd write that as 0.05. And T is the amount of time in years. So the amount of interest that you get from a savings account equals the amount that you put into it initially, multiplied by the interest rate that your bank promises to give you, multiplied by the time in years. Great. Let's apply this. So example 4.28 says Adnan has $40,000 to invest and hopes to earn 7.1% interest per year. he will put some of the money into a stock fund that earns 8% per year and the rest into bonds that earns 3% per year. How much money should he put into each fund? Great. Well, let's go ahead and organize our information into a table that looks like this. How would you know how to organize the table? Well, you would take principal and rate and time in 3 columns and set them equal to the interest column. Yes, and here I have just a column on the side that helps me discern which type of an account that I'm talking about. Okay, so there's a stock fund, right? There's a stock fund that I'm dealing with, and there are bonds. So I'll write that, stock and bonds. Stocks and bonds. There we go. And then this bottom column, maybe I just call that the total. So he wants to invest $40,000 into both of these accounts, right? So I know the grand total will be 40,000. So I'll put that down here. The total principal is $40,000. Well, I don't know how much is going to go into the stock fund and how much into the bonds of that $40,000. But I could call this variable S and this variable B for stocks and bonds. Instead of using just X and Y, why not use the first letter of each so that I can keep them easily distinguishable? What is the interest rate for each of these? Well, I've got an 8% for the stock fund. So I'll write that as 0.08, 8% as a decimal. And then 3% for the bonds, so I'll put 0.03. And he wants it to earn 7.1% interest total between the two accounts. So I'm going to put 0.071, right? 7.1% is 0.071 as a decimal. Question that comes up next is, what is the amount of time that we're dealing with? Well, we're talking about per year. Okay, so he wants to invest that and get that interest per year. So I'm just going to put time as 1 year in all the cases. Okay, so just 1, 1, 1. Nice and easy. So now I'm going to multiply S times 0.08 times 1 and write the interest expression right here. So that just is 0.08 times S. Okay. And then the bonds would be 0.03 times B. And then I get to the total, and I can multiply 40,000 times 0.071, right? And that will give me 2,840. That goes right here, 2,840. Awesome. Okay, at this point, we have filled out all the information. By the way, this time of 1 year made everything easy, right? Because when I multiply this times this times this, I don't even have to worry about multiplication by 1, because multiplying 1 is the same thing. So you see, I never show you the multiplication by 1 in this. I've simplified it. But we can take these two columns, this one and this one, and we can create a system of equations from them. Okay, that's the good thing about organizing this information into a table, is it helps you see very easily how you could create your system. So I have S plus B equals 40,000. That's my first equation of my system. And then 0.08 times S plus 0.03 times B equals 2,840. That's my second equation. Okay, and so now it becomes time to decide. Are we going to use substitution or elimination? I think it seems easier to use substitution in this case. So I'm going to just jump right in and solve the top equation for, in this case, S. I will solve it for S. Now you could solve for B as well. It doesn't matter. So you have a lot of options. At this point. You could do many different things, but we would have to come to the same answer if we did those things right. So I have S equals 40,000 minus B. I now take that and I substitute it in for S in the second equation. I'll rewrite the second equation with the substitution. 0.08 times 40,000 minus B plus 0.03 times B equals 2,840. This is now a linear equation that only has one variable, B. I can solve it for B. Here I go. So distribute, and I end up with 0.08 times 40,000, 3,200. Great. Minus 0.08 times B plus 0.03 times B equals 2,840. I'm going to subtract 3,200, that constant, so that it's with the other constant on the other side of the equation. And I am going to add 0.08b plus 0.03b, and that gives me negative 0.05b. And that's equal to 2,840 minus 3,200, which gives me negative 360. I will now divide negative 0.05 from left to right. And I have found that B, it equals 7,200. Okay? Well, what does that mean? That means $7,200 should be invested into the stock fund. Okay? And so now we can use this simple equation right here to find the rest that should be put into the stock fund. Sorry, B is $7,200. That is the bonds, right? And that's what we call B. B is the bonds, $7,200 of bonds. Now we have to find the stocks. Let's do it. We'll take this easy equation, S plus B equals 40,000. And we will replace B with 7,200. And now we'll subtract 7,200 from left to right. And we'll find the amount of money to put into stocks. Well, 40,000 minus 7,200 is $32,800. Okay? There we go. So we now know how much to put into the bonds and how much to put into the stocks. And that is going to yield a 7.1% interest per year, which is a pretty dang good interest rate. Okay? So there's that process, for example, 4.28. Let's try another. Rosie owes $21,540 on her 2 student loans. The interest rate on her bank loan is 10.5%, and the interest rate on the federal loan is 5.9%. The total amount of interest she paid last year was $1,669.68. What is the principal for each loan? Great. Let's just go ahead and break this down. Seems to me like we've got a federal loan and a bank loan. So the bank loaned her some money, and then the government loaned her some money, and this is the breakdown of it. So I'll just say bank and federal. How's that sound? And then I have a total. Now, the amount that she owes in her loans is $21,540. Okay, so that's the principal, $21,540. Now, there are different types of accounts. Like the bank loaned her at a rate of 10%, so I'll put 0.105 for the bank rate. And the federal rate was much better. It was only 0.059. She should have gotten all federal loans instead of bank loans, huh? The total amount of interest she paid last year was $1,669.68. That's where this goes. This goes right here. That's the total interest paid. Okay. And what else do I know? Well, the things that I don't know are like the principal, the amount that was put into the bank loan, or how much the bank gave her, I should say, how much that was. It's B, we'll call it. And then how much the federal government loaned her. Okay? So I'll call those B and F. And we're talking about the amount of interest paid just in the last year, right? So we're talking about 1 year of interest. So let's make this nice and easy. We're going to make the time 1 year for all of the stuff. Cool. So now I can multiply this times this times this to get the interest, right? And I'll create an expression. So this would be 0.105 times B, and this would be 0.059 times F. And I've got one equation for sure, right? This equation right here, I can add the pieces together and set them equal to the grand total. Oh, and I also have this equation right here that I can add those pieces together and get the grand and set it equal to the grand total. So I have found a system of equations from organizing this information. I have B plus F equals 21,540. That's my first equation. And I have 0.105 times B plus 0.059 times F equals $1,669.68. That's my second equation. Here's my system. Let's solve by substitution. How's that sound? I'll take my first equation and solve it for either B or F. It doesn't matter. In this case, I'll just decide to solve for B. So B equals 21,540 minus F. I have subtracted F to the other side. Now, using substitution, I can take this and replace it with B, because that's what B is. In the second equation, I will do that. And so I'll rewrite the equation. And let me fix one little thing. Little typo. There we go. Fixed. And so now I write 0.105 times 21,540 minus F plus 0.059 times F equals 1,669.68. And now this is a linear equation with only one variable, and you know the strategies to solve it. Let's distribute this stuff first. And I end up with $2,261.70. And I subtract off 0.105 times F, and then I add on the 0.059 times F, and that's still equal to $1,669.68. And then I subtract the constant from the left-hand side to the right-hand side. And I combine like terms, like this term and this term. And I'll write the simplified equation on the right-hand side here. I'm going to write, let's see here. I get negative 0.046 times F. That's when I add this and this together. I get negative 0.046 F. And that equals negative $592.02. Now, that's what I get when I take this minus this, right? I get this result. And so now I divide by negative 0.046 from left to right. And I find out that F equals $12,870. This is the amount for the federal loan. Let's go back and think about it. F, the amount for the federal loan is $12,870. Now, we need to find the amount of the bank loan. So we'll take that original equation, B plus F equals 21,540, and we will replace F with what we know it is, 12,870. B plus 12,870 is equal to 21,540. And then we simply subtract that 12,870 from left to right. And we find out that B is equal to 8,670. And B represents the bank loan. Okay, so this is the bank loan, the amount that the bank loaned to Rosie. And this was the federal loan, the amount that the federal government loaned to Rosie. Now, we remember, hey, that federal bank loan was a lot better of an interest rate than the interest rate that the bank provided. Okay, so now let's move forward, and we have one last objective in this lesson, and that is to solve applications of cost and revenue functions. So let's discuss cost and revenue functions here. Here are the definitions. The cost function is the cost to produce each unit times X, the number of units produced, plus the fixed cost. Okay, so let's say we have a business. What are the costs that go into running a business? Well, let's say we are making something like cookies. So there's a cost to making a cookie, and we multiply that by the amount of cookies that we make. All right? So the cost per unit of cookies times the number of units tells me how much I spent to make cookies. But there's also these added fixed costs at the end, and that's a constant. The fixed costs are like, how much is your rent? And how much do you pay your employees? There are a lot of other things in the mix than just the cost of producing something. Great. So this is called the cost function. There's also a revenue function. That's in business how much money that I bring in to the business, right? So the revenue function is the selling price of each unit times X, the number of units sold. So let's make this easy and think about cookies. So the revenue function R of X, it's equal to the selling price per unit. So how much are you selling the cookie for? Times the amount of cookies sold, right? X. And there's one last thing, if we want to know if we're making a profit or not, then what we can do is we can set these two equations equal to each other to find the break-even point, where I, turn losses into gains when it comes to profits. Okay, so the break-even point is when the revenue equals the costs, when these two functions equal each other. And this will take on meaning as we look at our last example for today. It's example 4.30. And so the manufacturer of a weight training bench spends $105 to build each bench and sells them for $245. The manufacturer has monthly fixed costs of $7,000. Part A, find the cost function when X benches are produced. Great. Well, my cost function is called C of X. We're calling it C because cost, right? So instead of calling the function f of x, since we're dealing with cost, we call it c of x. And so we're going to take the amount that it costs to build each bench, which is $105, right? Each bench costs $105 to build. And we multiply it by x, the number of benches that we produce. But then that's not our only costs. There are also fixed costs. So in this case, the manufacturer has monthly fixed costs of $7,000. So I have to add on that $7,000 of costs to the cost function. So we now have the cost function. Next, part B, find the revenue function, R. Okay, that's R of X. And we're using that instead of using f of X because we're talking about revenue. And so we know that they sell these benches, the manufacturer sells these benches for $245. So the R of X function is simple. It's just 245 times X, the number of benches sold. And part C says find the break-even point by graphing both the revenue and cost functions on the same grid. So I could take this linear equation and graph it, and then take this linear equation and graph it as well. I'll go ahead and do that right now. Okay, so maybe I focus on this r of x function first because it's got a y-intercept of 0. Like you see, there's a plus 0 at the end. This is just a linear equation. Y equals mx plus b. Y equals mx plus b. It's slope-intercept form of a line like we've discussed in previous videos. So my r of x function has a y-intercept of 0, so I go to 0 on the y-axis. And now my slope is 245 times x. Okay, so I'm going to have a rise of 245 for every run of 1 unit produced. So looking at this, I happen to have a point 50, 12,250 as one of the options, right? So if I input 50 into this function, and I get 245 times 50. That gives me 12,250, which is located somewhere like right here, 12,250. I'm going to eyeball it. Boom. Okay, so this point in question is 50, 12,250. That's that point. And so my revenue function looks like this. Now, you could have chosen any x value to plug in to this equation so that you could get a y value to plot another point. So if I had chosen an x value of 30, then my y value would have been some specific value right here. I could have chosen an x value of 40 to plug in for x. You could choose any value. Okay, so I chose 50. And then if I plug 50 into the cost function right here, then I will have a specific value that gets output. And it just so happens that plugging 50 into the cost function results in the same y value as the revenue function. So there I have a second point. Now my y-intercept is 7,000, so that's why I've plotted this point, 7,000. I plug 50 into the cost function, and it just so happens to spit out 12,250 like the other one did. And so now I can graph my cost function line right here. All right, so what have I just done? I've graphed my cost function, C of x, looks like this. And I've graphed my revenue function, R of x, and it looks like this. And it just so happens that I plugged in an x value of 50. Let's see. And I got a 12,250. Now, part D says find the break-even point, interpret what the break-even point means. Well, the break-even point is when the cost function equals the revenue function. So I take the cost function stuff, 105x plus 7,000, and I set it equal to the revenue function stuff, which is 245 times x. What have I just done? I set the cost function equal to the revenue function. Great. Now I could solve this for x. So I can actually take this 105x and subtract it from left to right so that all my terms with x in it are on the same side. And now I have 7,000 is equal to, well, 140x. And now I can divide by 140 from right to left. And I have solved for x. And it just so happens that 7,000 divided by 140 gives me 50. Okay, so the break-even point of how many benches need to be sold for the costs to equal the revenue to break even and start making a profit is 50 benches. I have to sell 50 benches total. All right, well, this has been lesson 4.3, which is the grand finale of our lessons regarding systems of equations. All right, and we had an extra little piece that we learned here at the end, the cost and revenue functions, which are critical functions for when we're dealing with business. Thank you and have a wonderful day.